This is Algebra 1, Term 4, Lesson 2, Vertical Motion. We'll begin in a Desmos activity, learning the vertical motion model, and then we'll go to a GeoGebra task, exploring the rates of change of a quadratic function, and we'll finish with a team task, falling off a cliff. So let's start with our Desmos activity. This is the Desmos Classroom Activity Vertical Motion, and you'll see that there are 9 different screens. So let's get started. First, they will press this button to toss this ball, and then they will type some text here. What do you notice about the height, the speed, the time in the air as it was tossed? They can toss it again if they need to. The next screen asks them to describe the graph, so now we're taking it a step further. The ball's on the left, and then the graph of the height versus time is on the right. Something you might want to talk about here is that the path of the ball is not the same as the graph. The ball's actually going directly up and directly down, but as we know, time is going to advance and the height's changing over time. So the path of the ball may follow a parabola if we throw it like in a horizontal direction, but in this case we're throwing it vertically, so we're not looking at the path of the ball, and that is a common misconception with these types of problems. They're being asked here about the function family and the rate of change in the graph. They may notice the speed of the ball is not constant. It gets slower and then it speeds up again. So have them talk about that. There are sample responses and teacher moves for you to read. Then this goes on to show the whole thing, and it's actually much easier to see what's happening. So it's the same graph, but now we have a little trail. I'm asking them if this function should be discrete or continuous. So read the sample responses and teacher moves there. And what do we know about the domain of this function in this context? Notice there are no numbers given in the graph, so we can't be too specific, but we should be able to describe the limits on the domain for this situation. Another question is, why is there only one x-intercept for the graph? You may notice this does not extend into the second quadrant, so have a conversation about that. Alright, now we're going to get into some more specificity, because now we have a grid and we have a ball that we can move along this curve. So they will move this along the curve, reading the numbers off and answering these questions. So they should type in these boxes. When they get to this one, there is nothing to drag, but they should click and drag on the curve so that they can see the points. The vertex is automatically, and the zeros are automatically displayed. All they have to do is hover over them or click them to see the coordinates that go along with those. So the question is, what are the x-intercepts and what do they represent in this context? Okay, this time they do have the little ball back. What is the y-intercept of the graph? And then it's going to ask them to explain what it means in this context once they've clicked on submit. And then finally, what is the value of y when x is 6? They will have to zoom out to see that because it is not visible on this graph. And then they will explain what that means. Again, I'll give you some teacher moves there for you to read, so be sure to check those out. All right, now we are finally being introduced to the vertical motion formula. H equals 1/2 gt squared plus vt plus h sub 0. H naught is what how they pronounce that. But they're basically being told the acceleration due to gravity in feet per second squared is -32. And so they're given the formula here, and then they're given this equation here. And so there's a need to figure out what these 3 numbers represent. The first one is the -16. Where does that come from? Why is that there? What does that 80 represent? And what does the 5 represent? So they're kind of getting a hang of what this formula means and how it works, and we will be using this pretty much for the rest of this assignment. Here's another one. They've got a graph and they have the points. Here's the equation, and then they're going to choose the statements that are true. So they will select all that apply. And that concludes the Desmos activity. I would take plenty of time here, probably about half of a class period at least, to go through that and make sure they're getting what this vertical motion model does. All right, the next thing we'll do, we'll go back to our slides and we're going to work in a GeoGebra task. So this task is using a GeoGebra app that has already created the model for them. They just use sliders to change the values for h sub 0 and v sub 0, which is initial velocity, or just v. And they're going to slide the t, and you'll see that in a second, to get these values in the table. Now it's really better to have like a split screen when they do this, so if your kids know how to do it, they can put their slide on the left and their app on the right, and they kind of work back and forth on this activity. So let's take a look at the GeoGebra app. Okay, so this is the GeoGebra app, and it's initially 80 and 84. The time starts at 0. The scale is 2. These can be all changed. So have them play around with it probably before you start to see what happens when they adjust the scale or adjust the velocity. Now they can have a negative velocity, but we kind of want a positive velocity on this one. And they can have a different starting height. So have them do that, and then they will create the graph and the model. And then it says fill in the table. So once they get these values in here, they will move this to 1, and they will get that value. Then they'll go to 2, and so forth, and 3. And as they get those values, they will fill out the table with those values. So on the slide here, they will paste a copy of the graph, which also has the equation in the graph. So that'll all be in one image. And then they will have all of these values filled out. Now this smaller table is to find the slope, or the rate of change, from one point to the next. So this first point to this second point, they would record their slopes in the table, and then I'm asking them to look at the rate of change of these slopes. So find the rates of change between the consecutive points in the table. So it's really a rate of change of the rate of change, if you think about it. And then what do you notice? Now I'm not going to say what they should notice here, but I have given you some notes in your teacher slides about what will happen, and it is quite interesting, and it actually helps them make more sense of that vertical motion model that they're using. So they'll do this here and then go to the next screen. It's the same process with a different starting height and a different initial velocity, but they're doing the same process twice. So if they didn't notice it on the first slide, they're almost certainly going to notice it here, because they're going to get kind of the same result with both of these. All right, our last activity is falling off a cliff. So here is today's team task, falling off a cliff. The students can work at the boards. You might have them do posters. I actually had them do this problem on poster paper, and they used, at that time we were still using the handheld graphing calculators, but they can of course use their Desmos calculator. So somebody will probably want to bring their Chromebook to the board, and they can create this vertical motion model using the information that is here. I wouldn't give them too much assistance, at least not initially. You might want to show them the base jumping video that I gave you a link to in your teacher guide. That would be a CNN little short video explaining what base jumping is. And then I've given them a link here in their task. This link here goes out to a Wikipedia article, so they can read a little bit more about what that is if they've never heard of it. And I've given you an example of what it might look like when your kids do this, but I've had them approach this in many different ways. I've done this in an Algebra 2 class, and they used the equations, but see, we're not using equations as much as far as solving, so they will probably not use that strategy since they haven't really been exposed to it. But graphs and tables, absolutely. Guess and check, sure, why not? So let them play around with these and see if they can come up with a reasonable answer. And I think this task was pretty fun. When my kids made these posters, they actually drew pictures of. They tried to draw a picture of a parachute and a person coming off of a cliff. So that was kind of interesting. But you can do this however you like. So this concludes our vertical motion lesson. Next time we'll look a little bit closer at those transformations. Y'all have a great day.